What are function closures? Let me just show you with an example on the page. So I've got a function called sayHello. We pass in a name. I create an internal variable called text, which is just hello with the name. And then I'm just printing it out. And then externally here, I'm just going to call sayHello with asim. So now, and when I run the file, we have hello asim printed out. Okay, but let's make this function a little bit more interesting. Instead of just printing out the name we pass in, I want it to return a function which then prints out a name. So let me just show you. So instead of just console logging the text, I'm now going to get the sayHello function to actually return a function, and inside that function I want to print out the text. Now when we run this, you're not going to see anything happen, and the reason is, let me actually run sayHello in the console. So there you go. So when running sayHello, it's now returning a function. So how do you call a function? Well, you call a function by using brackets. So we call sayHello and we pass in asim, and that returns a function. But to call that returned function, we need to use the open and closing brackets to invoke the function. So if I do this, there you can see now hello asim is getting printed on the screen. Okay, let me dig into that a little bit further. But before that, another thing we can do is I can do var sayAsim is equal to sayHello asim, and since this returns a function, sayAsim is now a function, the function that was returned. So let me refresh the page again. If I did sayAsim, there you go, it's a function. So if we want to call the function again, we just use the brackets and press enter, and there we go. Now we're calling the function that's returned from sayHello. And so let me then just finally put that in the actual main.js that we're working with. Let me refresh the page, and again, hello asim is getting printed out. But let's just take a moment to look at what's happening. So this goes against what we've been talking about throughout this entire section. And by that I mean, when we call sayAsim, we're calling this function here, and this function is printing out the text variable, this text variable here. But according to our scope rules, when sayHello exits, any variables declared inside it go out of scope and are deleted. So let me show you by actually debugging through the application. So I'm going to stick a breakpoint in here. I'm going to open up the debugger on the right hand side. I'm then going to restart our application. Here we go, we stop here. So we're now in the sayHello function. So we've been called from this line at the bottom here. The variable text has been created and we've assigned it to the string hello asim, but then we return. So we return here, okay? So now at this point, the sayHello function has returned. So anything declared internally inside its scope should now actually be deleted. What's happening when we call the sayAsim function? So let me dig into that. We're now calling the function that was returned from sayHello, and internally inside it, you can see that the text variable is still available, and it's then going to print that out. Normally, you would be correct in the statement that the text variable would be deleted as soon as the sayHello function has finished and exited. But the one exception for that is with closures. So when a function returns a function, so as the sayHello function is doing, it's returning a function. The function that's returned then keeps a reference to any variables that it needs to execute. So it's using the text variable, so it keeps a reference to the text variable. And we can see this actually right now from the right hand side. So on the right hand side, if we look at the scope section here, you can see it's got some local variables, which is a special variable called this, which we haven't gone through before in any of our lectures. But additionally, we have this thing called a closure. So here the closure is text. So what this is saying is this function here will first look inside its local scope for the text variable. It won't find it. It will then look inside this closure for the text variable, and it will find it there. But if it didn't find it there, it will then try and look in global scope. So that's what a closure is. It's a special set of references to variables that a function needs in order to execute, variables that are outside of this function's scope, okay? And then when we exit out of this, it's actually going to print out sayHello. So closures can seem pretty complex, but there's only a couple of things you need to really know about them. And one is that closures can refer to variables in outer scopes, in scopes external to itself. So this function, since it's being returned by another function, is going to be a closure, and it can refer to variables in scopes outside of itself, in outer scopes. So it's referring to a variable in its outer scope, which is in the scope of the sayHello function. So that's one. And the other thing to remember is it can refer to those variables in outer functions, even after those outer functions have returned. Right, so now we've got a basic understanding of closures, a very basic understanding of closures. But it's not normally enough just to express this level of knowledge. There's quite often one very specific code example which people give in interviews to test your knowledge of closures, and I'm just going to copy and paste that in now. Okay, so now we have an array called foo, and then every time we loop in the for loop, and we're going to loop 10 times, we then create a function that returns I. I is in the outer scope, so it's in global scope here. And then we're storing that inside the foo array, indexed by the same I variable. So again, this is creating another closure. So this function here, to work, this requires the I variable in its outer scope, okay? So what do you expect to actually get printed out? Honestly, spend just a second or two thinking this through, and just imagine what you think this will print out. Okay, now let's take a look. There we go. It's printing out 10, 10, 10. I bet that wasn't what you were expecting. You were probably expecting that foo0 would print out 0, because when foo0 was created, when the function here was created, I used to be 0. And again, you were probably assuming this line would print 1, because when foo1 was created, I was 1. And the same for foo2. I bet you expected that to print out 2. And this does catch a lot of JavaScript developers out, because even though you might think you have a grasp of closures, there's one really important fact that you're probably missing. And that fact is that when the closure is created, it doesn't get a copy of I. So the closure isn't a copy of I. Closure points to actual value of I in the outer scope. So by the time we call foo here, foo0 here, this loop has been exhausted and I is then 10. Okay, so when we call any of these functions, it's going to return I. I is always going to be 10. And so when we print it out, it's all going to be 10. And so that's what this particular interview question is trying to capture. Closure just points to the current value of whatever variables are used in its function body. The current value. So given that's the way closures function, how can we actually implement something that behaves like we want it to behave? So in this example, we want it to behave so it will actually print out 0, 1, 2. Now to do that, we can actually join forces with the previous topic, with the topic of immediately invoked function expressions, and use them both together to solve our problem. Okay, so what's happening here? Okay, for each loop through this for loop, we're going to execute this immediately invoked function. And remember, a function has its own internal scope. So when that function gets called, we create a variable called y, and we assign that variable to whatever the value of I was at that moment that this function was being executed. So when I is 0, y is going to be 0. When I is 2, y is going to be 2. And then what we're doing is we're just returning y instead of I in our closure. So now, if I run this again, you can see 0, 1, 2. That's what we would expect to happen. Let me just drop a breakpoint in here so you can see in a bit more detail what's going on. So let me refresh the page. Okay, here we go. So you can see that the first time we're looping through, y is equal to 0. Again, let me do it one more time. Y is equal to 1, 2, 3, 4. Keep on going like that. Okay. In fact, a better way to do it is let me just expand this out here and drop a breakpoint here instead. And let's get rid of the console and let's try it one more time. So now I want to break not when we're creating the foo array, but when we actually call foo0. I want to break there. So let me try one more time. So now when we're calling foo0, we're going to return y, and let's have a look here. So the closure here, we can see that the y is 0. This closure here, when it was created, it knew it needed to have access to the y variable, so it stored a reference to that y variable internally in its own closure, even though when this immediately invoked function exited, normally the y variable would just be deleted, but because this inner closure needed it, it stored a reference to the y variable, and now when we're calling it, it's actually getting the value of y when this iffy was created. Okay, so now when I call foo1, so I'm calling foo1 now. So now y is 1. Again, y is 2. So that's a neat trick with iffies that let you get around this problem of closures and the fact that closures only point to the current value of outer scope variables rather than the value at the time the closure was created. What you're doing is you're basically creating a scope just for this closure, and then you're basically snapshotting whatever values you need for that closure at that moment in time. Okay. But there's also one other possibly cleaner way of solving this problem as well. So with an IFI, when we invoke it with the brackets at the end, we can actually pass in variables. So let's imagine at this point we pass in I here. Okay. And since we're passing in I there, I can add, let's say, a Y here. And then let's do this. Okay. So when we loop through this for loop for the first time, we call this immediately invoked function, but we pass in I. Okay. And when I gets passed in, it gets passed into this function as Y. So we're now referencing it as Y. And because remember also, primitive types are passed by value, not by reference. This Y variable is not pointing, it's not referring to the same I variable in its outer scope. It's actually a copy. So then when we use Y and we return Y, we're returning the copy of Y when this function was immediately invoked. That essentially gives us pretty much the same functionality as we had before. So if I clear my shell, let me get rid of my shell. Then when I rerun, we then have 0, 1, 2 printed out again. So now we've covered 3 topics with closures. A, what is a closure? And that a closure can refer to outer scope variables of functions, even if that outer scope function has exited. But then I showed you a really important fact about closures, which is that it points to the current value of the outer scope variable, not the value of that outer scope variable when that closure was created. And so this example with the for loop is a very popular example that interviewers give candidates to see if they have that level of understanding. But then we've gone one step further, and I hope you go one step further in the interview and show the interviewer that if they do want the behavior they expected, they can achieve that with IFIs, with immediately invoked function expressions. And that's really what you want to do in these interviews. You always want to go one step further.